Hello students, class 12, welcome back. Today I am continuing again the histogram chart, but more facilitated and more functionality you can see. Okay, last time I have discussed about histogram. In histogram, one new thing is in this we can represent only frequency of our numerical data. Okay, so in histogram, some more thing you can see. Here new thing is cumulative histogram, okay, and frequency polygon chart. Okay students, so this thing is very simple, you can see. So first we think what is uh, frequency polygon. A frequency polygon is a type of frequency distribution, okay, graph. In a frequency polygon, the number of observations is marked with a single point at the midpoint of an interval, a straight line, then connects each set of points. It is easy to compare two or more distribution on the same set of axes. Okay, so this is our frequency polygon and cumulative histogram we can see. Okay, so two new chart we can see. So you can see first first we understand what is cumulative. You can see the data is month and cells. Month Jan 5, Feb 4, March 6, April 2, May 7 and June 8. Okay, but this data we cannot directly use in our histogram. Okay, first we take a numerical column. Our numerical column is cells. Okay, what is the minimum value? Minimum value you can see 2. What is the maximum value? You can see 8. Okay, minimum to maximum 8. So this is our range, but I want to divide this range 2 to 8 again, fixed number of interval. Okay, so we can find frequency in between intervals. So here I am decide means I want to create 2 to 4, okay, then 4 to 6 and 6 to 8. So you can see 2 to 4 only one cell, okay, 4 to 6 only two cells, and 6 to 8 you can see only three cells. Okay, but here I want to create cumulative histogram, not a simple histogram. So again I want to sum this frequency from top to bottom. So you can see frequency start from again same to same, cumulative 1, then 1 plus 2. Okay, above and below number we can add. So 1 plus 2 you can see 3, again this 3, and finally frequency 3 we can add, 3 plus 3 6. So in this style, in this chaining, okay, last result and frequency new value we can add, so we can get cumulative numerical data. So our data is 1 3 6. Okay, so in 2 to 4 range cumulative is 1, in 4 to 6 cumulative is 3, in 6 to 8 cumulative 6. Okay, so now this data we can plot in our chart. So you can see here 2 to 4 you can see cumulative 1 in this chart, 4 to 6 cumulative you can see 3, and 6 to 8 you can see 6. Okay, so analysis after analysis you can see in our language. But for this you simply use same thing as it is, we can use our histogram chart, but here new thing is here I'm using one thing only. In our cumulative is equal to true, only this parameter we need additional, cumulative is equal to true, only this parameter. Otherwise same thing we can use as it is. Import pandas spd, import matplot pyplot splt, x.pd.data frame, okay, plt.hist, because in histogram we need numerical column. So x cells means here I am deciding two fixed intervals, so 2 to 4, 4 to 6 and 6 to 8. And here I am not want simple histogram, I want only cumulative histogram. So here I am using cumulative is equal to true. Okay, this thing is important. Other thing, plt dot title, plt.x label, plt.y label, and plt.legend, and plt.save figure, and plt.show. This command is common in every chart. So you give proper title. You can ox axis you give proper title. Okay, in OY axis you give proper title, sales, frequency, values, and legend we can put to show what is the plotting reference. And we can save this chart also in PDF file in advance. We can decide in D drive what will be the file name, hist.pdf, and plt.show command we always use to see our result. Okay students, now next program is frequency polygon. Okay, in this chart we only, because according to name polygon means here we can show only boundaries. Here we can show only boundaries. Okay, so you can see same thing. Okay, but here we need hist type is equal to step. Hist type is equal to step when you use. So this show only boundaries. Okay, in histogram it show only boundaries, or in these boundaries between interval 2 to 4. Okay, in middle we plot a circle. 4 to 6 in middle we plot a circle, and 6 to 8 we can plot a circle. Then we can connect each circle. So finally we will get a particular polygon. Okay, so we can say this is a frequency polygon. Okay, other thing as it is we can use here new parameter we use for frequency polygon, hist type is equal to step. Okay, keep in mind other things same as it is we can use data frame, hist, x cells, beans as it is, but here I want to show only boundaries. And in interval between value we can put as marker, then we can connect each marker to each other, so we will get a polygon. So we can say this is a frequency polygon, but before we must use hist type is equal to step into plt.hist function. This parameter is important to see frequency polygon chart. So you can see plt.title, x label, y label, legend, save figure, plt.show. This command is common, and as it is we can use. Okay, so we can change according to our choice. Now new thing is, suppose this histogram I want to show just like a vertical bar graph, just like a vertical bar graph. We know very well when you use bar graph between bars, already some gap always present, but in histogram there is no gap. Okay, continuation you can see our chart. Okay, in chart, but suppose I want to behave just like a bar chart. Okay, so I want to maintain gap between bars. Okay, it is possible. So we can reduce the width of bars, so it will generate a gap and we can behave just like a bar chart. Simple, we can change one thing parameter, r width is equal to 0.5. Okay, so 0.9. Okay, so it will reduce the width, so you can see it will, so automatically it will give gap. Okay, by default this is 1, r width is equal to 1. When width is 1, so there is no gap, by default 1 point. But when you reduce below 1 point any value, so it will reduce the width, so it will produce a gap between bars. So this chart behave just like a bar chart, but actually this is a histogram chart. It shows only the frequency of numerical data. So one parameter r width is equal to 0.9. Other thing as it is we can use PDDO data frame, title X label. Okay. So today I am discussing we can change this histogram in different situation and different purpose. For cumulative purpose, we can use cumulative is equal to true. Suppose you want to show only boundaries, and in boundaries in interval we can use a midpoint, and this midpoint we connect each other, so it will become a frequency polygon. We must use hist type is equal to step. Or suppose this histogram we can behave just like a vertical bar graph, so we can just only reduce the r width. Okay, so you can see this is our histogram chart with new additional features. Okay, thank you students.